Data which describes data is called metadata. For example, we may have a list of customers, say in a spreadsheet or a table in a database, and we may apply a tag like this. Completeness, 100%. Another example of metadata is built into files. Information like file name, creation date, and last modified date. You can see this metadata when you explore files on a personal computer. Metadata is also used in databases. A simple example is the column headers in a table of information. These describe what is shown in the column. In Microsoft Excel, you can add comments to cells, for example, to describe more fully what is in that cell or that column if it's a header cell. This is metadata. Metadata can be extremely useful when we think about data governance. Imagine we had a way of tagging data with descriptors like these. Highly confidential. Contains personal information. Retain until XYZ date. You might imagine we could build software tools to read this metadata and to ensure governance policies are followed. For example, restricting access to data with personal information in it. Metadata can also be used to help find data. Imagine we tagged a dataset with these. Active customers. Completeness, 100%. Last modified. Imagine it's yesterday's date. If you wanted the latest list of customers for a marketing campaign, faced with myriad versions of data with customer information inside, finding this one through an easy search interface would be hugely valuable. You wouldn't even need to look inside the file. The metadata tells you all you need to make your choice. I would go as far as to say that data management is not possible without including metadata management too. The challenge is there is no standardization in terms of tools to practically achieve it. The path to metadata management is complex and will require navigation of a plethora of tools and technologies. You might have spotted that without some guidance, the creation of metadata tags could become like the Wild West, a total free-for-all. This is because different stakeholders will have different requirements, perspectives, and understanding of what is needed. To deal with this, and indeed many other areas of potential misunderstanding, we need to create some structure. Business glossaries and data dictionaries are two common ways of achieving this. Business glossaries and data dictionaries. A business glossary is a centralized repository of definitions for business terms and concepts. It is used to ensure that everyone in the organization uses the same language when talking about business. A business glossary is typically created and maintained by business teams under the guidance of data governance policies, and it is used by a variety of stakeholders, including business analysts, data analysts, and IT professionals. A data dictionary is a technical document that defines the structure and relationships of data. It is used to document the data elements, their definitions, and their relationships to each other. A data dictionary is typically created and maintained by the IT team, and it is used by data analysts, developers, and other IT professionals. The main difference between a business glossary and a data dictionary is that a business glossary focuses on the business meaning of data, while a data dictionary focuses on the technical structure of data. Another difference is that a business glossary is typically created and maintained by the business team, data stewards, while a data dictionary is typically created and maintained by the IT team, data architects. In both cases, the data governance team also needs to provide some oversight and will often be the initiators for their creation. A business glossary is used to Ensure that everyone in the organisation uses the same language when talking about data. Improve communication and collaboration between business and IT teams. Reduce ambiguity and confusion about business terms and concepts. Support business process improvement initiatives. And facilitate data governance efforts. A data dictionary is used to document the structure and relationships of data in a data system. Improve the quality and accuracy of data. Reduce data redundancy. And support data governance efforts.